All right, let's try a little thought experiment. Picture this. It's payday. Everyone's checking their accounts, waiting for that deposit. But oh, something's wrong. Your payroll system is throwing errors left and right.
Mm.
People are calling, emails are flying. Some got paid less, some maybe not at all. Absolute chaos. And the reason? It turns out this one critical timesheet file, the one that feeds the whole system, well, it arrived empty.
Yeah.
Just nothing inside except the header row.
Yeah, it sounds small, doesn't it? An empty file, but the knock-on effects, it can be huge.
Exactly. It's not just a glitch.
Right.
We're talking serious stuff, upset employees, major compliance headaches,
Mm.
and, people just stop trusting the systems that are supposed to make things easier.
Mm-hmm.
So today, we're going to dive deep into, well, a pretty neat solution for this exact problem. It's basically an automated watchdog system.
Right.
It spots these empty files before they mess everything up. We're looking at something called a Slack-enabled payroll file health alert system, built using Databricks.
And we've got a really good document here, prepared by someone who's built this kind of thing, laying out this whole data quality monitoring and alerting pipeline.
Yeah, it's quite detailed. So let's get into it. Let's unpack how this Guardian actually works.
It really is amazing how fragile some processes can be, isn't it? Payroll is just so dependent on getting those timesheet files accurately, like every single day or week from HR systems or maybe project tools.
Totally. And when they show up blank,
Mm.
maybe an export failed somewhere or the upload just timed out.
Exactly. The impact is immediate, it's damaging, and often, like you said, nobody notices until it's way too late.
And it's more than just, an inconvenience, right? We're talking people's actual paychecks. But what about the sort of slower burn damage, the trust thing you mentioned?
Oh, absolutely. Beyond the immediate ouch of underpayments or mispayments, you've got compliance risks. Think legal trouble, regulatory fines, stuff no business wants. And yeah, the trust factor. If payroll keeps messing up because of bad data feeds, people lose faith, not just in payroll, but potentially in all the automated systems. It kind of erodes confidence across the board.
So let's make it concrete. The source material gives a good example. You've got one file, let's call it timesheet 2025-0709.csv.
All right.
Open it up, you see, employee E001 worked 8 hours, E002 worked 7.5, both on project PRJ001. Looks good. That's a healthy file.
Makes sense. Got data.
But then the next day, timesheet 2025-07-10.csv lands. Same file name format. Looks totally legit from the outside. It even has the header row, employee date, hours worked, project code.
Uh-huh.
But below that header, zilch, nada,
Yeah.
empty. That's the sneaky problem this whole system is designed to catch.
Right. That's the silent killer. So how does this automated guardian, as you called it, actually stop it?
Good question.
Well, the whole setup in Databricks is essentially this data quality monitoring alerting pipeline. It's all about being proactive, acting like a gatekeeper for the data coming in.
Okay, so step one is just seeing the files arrive, right? How does it even know a new file has landed in the drop zone?
Yeah, that's where the smart ingestion part comes in, using something called autoloader. Think of it as having someone constantly watching that input folder, mtra timesheet landing in this case.
Uh-huh.
Autoloader sees a new CSV file pop up, grabs it, figures out the header automatically, and starts loading the data. But here's the really clever bit. As it reads each row, it tags it with the full path of the file it came from. Input file name, technically speaking.
Ah, okay. And that tagging, that's crucial, right? It's like knowing the provenance of everything.
Exactly. It's data lineage 101. Without knowing which file a specific row came from, debugging becomes a nightmare later on. You wouldn't know which file was empty or bad.
Right. You just have a bunch of errors downstream and no clue where they started.
Precisely. So that tag enables the next step, temporary staging and validation. The raw data, with its tags, first gets streamed into a temporary delta table.
Delta table. Okay, that's like a more robust version-controlled table for this kind of big data stuff. Yeah.
You got it. Super reliable. Then you have a separate process, like a batch job, that runs regularly, maybe every 15 minutes or so, and its job is to look at the files that just landed in that temporary table.
Okay, so the batch job is the inspector. How does it tell the good files from the empty ones?
This is the core logic, the aha moment, really. It simply counts the number of data rows associated with each source file path in that temporary table.
So it ignores the header row count.
Exactly. It looks for actual data. If the count for a file is more than 0, great. It's classified as a valid file.
And if the count is 0?
Bingo. Flagged as invalid file. Because it means only the header was present. No actual timesheet entries. The beauty here is catching it before that empty file's nothingness gets processed as real data downstream.
It's like a bouncer at the door, basically. Header-only files don't get in.
That's a great way to put it. It's proactive prevention. Instead of cleaning up a mess later, you stop the bad data at the gate. It really shifts things towards better data governance.
Okay, that seems pretty solid for empty files. But, what if a file isn't empty but has, like, weird characters or the hours work are negative numbers or something? Can this system handle that too?
That's a really good point. This specific setup we're discussing focuses on the empty file use case, which is surprisingly common, but the architecture itself, absolutely extendable.
No.
You could easily add more validation rules in that batch job. Check for specific data types, look for values outside a normal range, check for duplicates, whatever quality rules your data needs. The principle's the same. Validate early, segregate bad data.
Gotcha. So back to the empty files. Once it's classified them, valid or invalid, what happens next? Does it just delete the bad ones?
No, not delete. It segregates. The valid data gets routed onwards, usually to what's called the bronze layer in a data lake architecture. I meant bronze payroll valid in this example. That's the first stop for raw but validated data.
Okay, so bronze is like raw but approved.
Pretty much. And the invalid files, the empty ones, they get moved to a different area, say MNT bronze payroll invalid. And crucially, an entry is made in a log table MNT logs payroll validation, needing the file name, the timestamp, and the issue, like empty timesheet file.
Logging is key, so you have a record of what went wrong and when.
Absolutely. And the most important principle, only the data from those valid files makes it through to the actual payroll processing steps. The empty ones are quarantined and logged, preventing any downstream chaos.
Okay, detection is awesome. Finding the problem early is
Yes.
huge. But, if a tree falls in the forest, if the system finds an empty file but doesn't tell anyone.
It doesn't help much, right? Exactly. Detection needs alerting. You need to get that information to a human who can actually investigate why the file was empty and fix the source issue.
Right. I remember once spending ages trying to find one tiny error in a report. An alert like this would have been a lifesaver.
We've all been there. So how does it raise the alarm? There are a few good ways. Option 1, probably the quickest for team visibility, is using a Slack webhook.
Ah, yeah, Slack. Pretty much everyone uses it.
Yeah.
How does that work?
It's surprisingly simple. In Slack, you set up what's called an incoming webhook for a specific channel, maybe one you create called #data_pipeline_alerts or something.
Okay.
Slack gives you a unique URL. Then back in the Databricks job, when it finds an empty file, a little bit of Python code just sends a message to that URL.
And boom, it pops up in the Slack channel.
Yep, something clear and simple like, warning. Hey team, found 2 empty timesheet files. Timesheet 2025-07-10.csv, timesheet 2025-07-11.csv. Quick, easy setup, gets the right eyes on it fast.
Nice. I like that. Very direct. Keeps the team in the loop. Better than finding out your paycheck is 0.
Definitely. Now, if you need something maybe a bit more formal or want to target specific individuals, email is another option.
Okay, standard email alerts. How's that done?
Well, the basic way is using standard SMTP libraries like smtplib in Python. You need your email server details, login credentials, maybe open up firewall ports.
Right, the usual email setup stuff.
Yeah, it works fine for direct notifications, sends an email straight to someone's inbox, controlled direct.
But SMTP can sometimes be a bit fiddly and maybe not ideal for like huge scale or if you want really robust logging of alerts.
That's a fair point. For bigger operations, or if you want alerts integrated tightly with your cloud environment, you'd look at cloud-native services.
Okay, like what? What are the options there?
Depends on your cloud. If you're on Azure, you might use Logic apps or maybe SendGrid, triggered by the Databricks notebook. On AWS, you'd probably use SNS, their notification service, maybe coupled with a Lambda function triggered from Databricks using their SDK.
Right.
And GCP has similar tools like Cloud Functions, maybe calling Mailgun or another email API. These cloud services give you way more scalability, better monitoring, centralized logging of alerts. It's more enterprise grade.
Makes sense. So, quick summary on alerts. Slack for fast team stuff, basic SMTP for direct email,
Yeah.
and then the cloud, big guns for scalability and integration. Good to have options.
Exactly. Choose the right tool for the job.
Now, this whole thing, we've been talking payroll, payroll, payroll. But this idea, this pattern, it feels bigger than just timesheets, doesn't it?
Oh, absolutely. The payroll example is great because it's so relatable and the impact is clear. But the underlying principle, validating incoming files before they pollute your data lake or warehouse, that applies everywhere.
So any system that relies on files coming in from somewhere else could use this.
Pretty much. Think about files from suppliers, data feeds from partners, sensor readings. The source material actually mentions Shell, the energy company.
Shell. What are they doing with this? It's not payroll, I assume.
No, definitely not payroll. Their challenge is dealing with industrial IoT data. They get telemetry files pouring in from thousands of oil rigs, huge volumes.
Wow, okay, thousands of rigs.
Wow.
That's a ton of data. So are they checking for empty files too, or is it different for sensor data?
It's the same core idea, just maybe slightly different checks. For them, an invalid file might not be strictly empty, but maybe it's corrupted, or missing critical header info, or the sensor readings are clearly nonsensical.
Ah, so the definition of bad changes, but the pattern of checking early and separating is the same.
Exactly that. They use their stack, Azure Data Lake, Databricks, Delta Lake, to filter out these bad or incomplete telemetry files before they land in their main bronze layer, ensuring only usable sensor data gets through for analysis with tools like Power BI.
That's fascinating. So from payroll CSVs to massive IoT streams, the fundamental problem and the Databricks Delta Lake solution pattern hold up.
It really does. It shows how versatile this approach is. Different industry, different data types, same core need for data quality at the front door.
So wrapping this up then, we've walked through this really smart automated system. It takes what could be a major crisis payroll going wrong and turns it into, well, just a notification.
A manageable alert.
Yeah. Instead of scrambling after the damage is done, you get a heads up. Hey, this file looks empty. Maybe check the source. It's that shift from being reactive to being proactive. Data guardianship, as you called it.
Precisely. It puts you back in control.
So here's something to think about as we finish. We know data runs pretty much everything these days, right? This makes you wonder, where else could a simple empty file, or maybe just some subtly corrupted data, be lurking unnoticed? Silently causing problems in systems we rely on every day. You know, what other processes out there, maybe even ones you interact with without thinking, could really benefit from having this kind of automated data guardian standing watch, making sure the foundation is solid before anything else gets built on top?